The fourth planet from the Sun has long captured the imagination of scientists and explorers alike. With its relatively close proximity to Earth and signs of ancient water flows, Mars appears to be one of the most promising candidates for human colonization. However, one of the major obstacles to transforming Mars into a livable environment is its lack of a global magnetic field. On Earth, the magnetic field shields us from harmful solar and cosmic radiation, deflecting charged particles from the solar wind. Mars, in contrast, lost its magnetic field billions of years ago. As a result, its thin atmosphere was gradually stripped away by solar wind, leaving a cold, dry, and exposed surface. Temperatures average about minus 63 degrees Celsius, minus 81 degrees Fahrenheit, and the atmosphere is less than 1% the density of Earth's, composed mostly of carbon dioxide. Without a magnetic field and a thicker atmosphere, any attempt to establish long-term human settlements would face severe challenges, including radiation exposure, lack of breathable air, and extreme cold. NASA and other scientists have been exploring theoretical models to terraform Mars. In other words, to artificially engineer the environment to make it more Earth-like.
One of the most radical yet scientifically grounded ideas proposed is the creation of an artificial magnetic field around Mars. This concept was explored in a 2017 NASA workshop titled Planetary Science Vision 2050. Instead of trying to restore Mars's core dynamo, which is far beyond current technological capabilities, the idea is to place a large magnetic dipole at the Mars-Sun L1 Lagrange point, a stable position between the planet and the Sun. At this location, a powerful magnetic field generator could emit a stream of charged particles or a controlled magnetic flux that would deflect solar wind away from Mars, much like Earth's magnetosphere does. This magnetic shield wouldn't need to wrap around the entire planet. By stopping the solar wind upstream, the atmosphere would no longer be eroded, and Mars could begin to slowly rebuild and retain its atmospheric gases. With a more stable atmosphere, scientists theorize that greenhouse gases trapped in the Martian soil and polar ice caps, such as CO2, would begin to accumulate in the atmosphere over time. This increase in greenhouse gases would trap more heat from sunlight, raising surface temperatures in a controlled way. As the atmospheric pressure rises and temperatures increase, Mars could enter a self-reinforcing warming cycle. More CO2 would sublimate from the polar caps, increasing the greenhouse effect. In time, water ice might melt into liquid water in some areas, enabling the potential for plant life or algae that could further contribute to oxygen production. While the timeline for such warming would still take decades to centuries, the initial steps are crucial. Simulations suggest that with the protection of a magnetic shield and artificial warming, Mars's climate could become significantly more stable and Earth-like. NASA has not yet committed to building such a magnetic shield, but the concept shows how advanced planetary engineering could play a role in the future of space colonization. The combination of protecting the Martian atmosphere and amplifying greenhouse warming represents a bold vision for making Mars a second home for humanity.